Alright, in this video we're going to be talking about how to find the surface area and volume of a square pyramid. So we start with some vocab here at the top of the page. A pyramid is a polyhedron in which the base is a polygon and the remaining faces are triangles with a common vertex that does not lie in the same plane as the base. The altitude or height of the pyramid is the perpendicular distance between the base and the vertex. A regular pyramid has a regular polygon for its base, and its height meets the base at its center. The slant height of a regular pyramid is the altitude of any of the triangular faces. The pyramid seen at the right is a square pyramid. So in this case, we're starting with a square pyramid, which means each of these side lengths for the base are going to be the same length. In fact, all of the pyramids we will be working with will have regular polygons for their bases, whether that be a regular quadrilateral, as we see here, which we call a square, or an equilateral triangle, etc. So in terms of the apothem, as we've defined it before, it is the distance between the center of the base and the midpoint of one of the sides. So this point here on that base edge is going to divide that base edge into two congruent parts. Reading on a little further, in a square pyramid, the apothem is equal to half of the length of one side of the square. So if the side of the square here is given, say it's 20 units long, then the apothem will be half of that, or 10 units long. If the apothem is 8 units long, if the side of the square is 8 units long, then the apothem would be half of 8, or 4 units long. So in a square pyramid, the apothem is half as long as one of the sides. Now once we have kind of these various portions drawn into the diagram, we can see that here again we've got a right triangle, which means the Pythagorean theorem. We call the apothem, of course, a, that lowercase a. Height we refer to as h, and the slant height we refer to as L. So our Pythagorean theorem in this case, a squared plus h squared equals L squared. You will need, for the formulas, as we'll look at in just a moment, you will need both h and L. Only one of those is going to be given in the problem. So you'll have to come back to this Pythagorean theorem first to find whichever h or L is not given, and then determine your capital B, capital P values in order to find your surface area and volume. So in terms of the surface area, we've seen this formula before. It's the area of the base plus 1/2 times the perimeter of the base times the slant height. So there we need L. And then the volume of any pyramid is 1/3 times the area of the base times the height, and there we need h. So we need both h and L before we proceed to these two formulas. So with that in mind, let's look at a couple of examples. In each of the problems with these square pyramids, you're going to be given the base edge length and either the height or the slant height. So we'll look at an example of each just to kind of give you some familiarity with that. So we need 3 values before we start. We need capital B, the area of the base, capital P, the perimeter of the base, and we need the height and slant height. I guess that's 4 values, not 3. So in this case, let's start with capital B. Area of a base. Since the base is a square, the area of the square would be 30 times itself, or 30 squared, which gives us a capital B value of 900. For P, that capital P value is the perimeter of the base. So in this case, the base has 4 edges, each of which is 30 units long. So 4 times 30 gives us a value of 120 for that P value. We're told the height is 5, so there's our H value. And now we need L, and that's where the right triangle is going to come into play. So L is this distance straight down the center of one of these triangular faces. It's going to cut that base edge into 2 congruent parts. So since the base edge was 30, these are each 15. The height, as we've said, goes down from the vertex to the center of the base, and we know the height is 5 units long in this case. For a square pyramid, the apothem, which goes from that center to the midpoint of the base edge, the apothem is half as long as the base edge. So since our base edge here is 30 units long, the apothem will have a length of 15 units. Alright, so let's set up our Pythagorean theorem and use that to find L, the slant height. So 5 squared plus 15 squared equals L squared. 5 squared plus 15 squared, 250. So L will be the square root of 250. That does have a decimal approximation that we could give it, but I'm not going to mess with that at this point because I don't want to round anything in these values. I want to round the surface area and the volume, but not these individual values. All right, so the surface area. The area of the base plus 1/2 times the perimeter of the base times the slant height. So in this case, B is 900 plus 1/2 times P, which is 120, times L, the square root of 250. And then we go to our magical calculator. 900 plus 1/2 times 120 times the square root of 250. And we get a magical answer of 1848.68. And our label in this case is units squared, since it's a surface area. And that takes care of one of our solutions. All right, now for the volume. 1/3 times the area of the base times the height. So in this case, 1/3 of 900 times the height, 5. Gives us a volume of 1/3 times 900 times 5. 1,500 units cubed. And that's the general process that you want to kind of employ when finding the surface area and volume of a square pyramid. So determine the value of B, value of P, and know both H and L before you proceed to the surface area and volume. All right, so let's look at our second example in which we are given the slant height instead of the height. So here we're given L, which means in the triangle, that distance will be 12. Kind of continuing on that theme, we have to find H. And let's see, the apothem, which is half of the base edge for a square pyramid. Since the base edge is 20 units long, the apothem will be 10 units long. All right, so let's set up our capital B, area of the base. 20 times itself, 400. Perimeter of the base is 4 edges, each of which is 20 units long. So the perimeter in that case is 80. And now we're ready to use our Pythagorean theorem. So 10 squared, A squared, plus H squared equals L squared, and L is 12. All right, so 144 minus 100 gives us 44, so H is the square root of 44. There again, it's not the final answer, so I'm not going to worry about rounding it. All right, surface area. Base plus 1/2 PL. Okay, so substituting, we get 400 plus 1/2 of 80 times L, which was our 12 we were given. 400 plus 1/2 times 80 times 12. We get a surface area of 880 units squared. Okay, now let's deal with that volume. Volume area is 1/3 times the area of the base times the height. 1/3 times 400 times the square root of 44. 1/3 times 400 times the square root of 44. We get a volume of 884.43 units cubed. And that's how you find the surface area and volume of a square pyramid.